Video we have learned how we can statistically promote the model. Now in this video we are going to learn about the drift detection in MLflow. Over a time we want to calculate how our model performance is getting degraded or not. So this is also very important in the MLflow lifecycle. We need to detect as early as possible if the model is getting drifted away. So we are going to take inspiration from our previous codes, and I have done the code explanation in the episode 1, so feel free to watch it, why these configurations are set. So once this is done, your configuration, set the MLflow tracking URI, and this time we are going to set new experiment, which is batch scoring. Right now we have only 2 experiment, and here we have done the model sweeping, simple model train, model promotion. Now let's collect some data which we will use to check for drift. Usually this is a new live data that you might have labeled, or in case of unsupervised learning, unlabeled data that you will take. For now I'm going to use the same data because we want to learn the method. Data can be anything. Now you need to enter into the with context. You need to provide your run name. MLflow will start the run. We are going to specify which model for which we want to do. We have been using the smartphone return random forest model. We had trained it, we have done experiment with it. Now let's collect that model. The next sklearn model loads that model, makes prediction on the X that we have collected, preferably the drift data, and then we are also going to collect the prediction probabilities. Once we get this, let's save the predictions as prediction data frame, all the predictions that we have got, and also the probability, and let's save the prediction in a CSV file because this is a auditable artifact we are creating so that anyone can refer it later on. So let's save this and log this artifact in MLflow so that it can be visible in the UI itself. Now let's do a simple drift check. Let's select include all numerical data column, and let's do the collect some of the reference window. Let's mark some of the reference window as drift and leave other windows as usual. This is where we are calculating the mean of those columns, numerical columns. Then we are going to subtract it from the normal one, the drifted one, subtracting the normal one, and then we are doing the calculation, the feature, mean, current mean, delta mean, reference, standard, deviation. This report we are going to save it as the report.csv, and then we are logging the artifact. Now we can this is a quick drift flag. Any large relative mean shift, we are going to flag it. So we are simple logic is drift from diff df mean will check if multiplying by 0.2 reference standard is it standard deviation is about 20% about the mean. If this is true, that is mean we have been drifted away. Then we'll calculate the drift ratio, and then we are going to log that artifact. So this way you will be getting the information of whether our model is getting drifted away or not. So let's do this and let's run it. And For running this, let's Python drifts batch score. So it has created new experiment batch scoring. Here all of the drift informations are present, all of the artifacts, drift reports, predictions are present. It happened really fast because the data was very low, and also this report can be audited with more webhooks enabled to also trigger the training, so that you get new model experiment and then you redeploy new model. So from here it's a design choice. You just need to remember like how can you achieve this. Thank you.